let me open problem set 1. There's an initial step of setting up the IDE, and we have to submit hello. Hello is just the hello world equivalent. So if I go through this, let me just create a folder here real quick. So okay, so let me create hello PSET1, and then hello, and then change directory into PSET1 hello. Okay, so after that, what we want to do is we want to create a file here. I'll just touch hello.c. So we created a .c file, and let's see what this wants to do. So it's saying, okay, you just want us to copy paste these files. So Control C, Control V, paste it. Okay, so this is hello world. And but I think for this particular assignment, it actually wants you to say hello followed by your name, right? So at least that's what I remember, at least. Okay, so let's try to think about this. So instead of printing hello world, we want to print hello followed by some name. So we'll just do hello %s followed by name, and then we have to get the name from the user. So I believe the CS50 library has some function, this one I think, get string, which returns a const char pointer. So I'm gonna go ahead and copy this. So string name equals get string, what's your name? And then, oh, it also gives a printf. So let me go ahead and do that. So what's your name? And then you also have to include CS50.h because this getString function is defined in CS50.h. So after we do this, then I think we're good to go. Let's just go back to the terminal, do make hello. Okay, so now the thing about make is that it compiles with Clang and also with other warning flags, which are really important, as well as the CS50 library, which is also gives us, which statically links the compile time all the libraries together so that we can use functions like getString, etc. So now if I go ahead and execute hello, what's your name? I don't know, programmer or something. Hello, programmer. Okay, so this looks good. Let's execute the check 50. This might take some time. Okay, so this works. I'm going to go ahead and submit it and ignore. I don't know if I want to run the style actually. I usually don't worry too much about style as long as it's working. But I guess, okay. So we'll do that, and I'm going to supply the input T. Okay. Okay, so let's go and see the results. Open, it's gonna open a new tab. Let's wait on the results, I guess. Okay, meanwhile that's going on, let's go ahead and create another directory. So here, let me clear it out, make directory for the next one, Mario less. And then Mario less, touch Mario.c. Just gonna create an empty file, Mario.c, okay. Let me go back. Okay, 4.4, okay, cool. So next one is Mario, okay. So for Mario, what we want to do is we want to print this pyramid structure inside Mario. So that's the task here. So as an example, right, when you're playing the Mario video game, you see this particular pyramid, which has a height, in this case, of 1, 2, 3, 4, 5, 6, 7, 8. So this pyramid has height 8, and we want to print this pyramid using a console, on the console pretty much, using some hashtags and spaces. So how might we do that, right? So here's the example that they give us. If we were to execute our program with height 8, it would print the entire pyramid with 8 as height, in which it has with some spaces as well as some hashtags. And then same with 4, same with 2. There's also some invalid input that the user can provide, which you should ignore and keep on reprompting the user until you get a valid integer, right? Between, I guess the constraints for this problem is between 1 to 8, I believe, 1 to 8 inclusive. Okay, so yeah, so let's sort of think about how we can approach this problem. So first we have to get an input according to what they describe here, right? So how might we get an input? That's just CS50 already provides a simple function called get int, so we can just take input. So that'd be a good starting point, I guess, for this particular problem. So I think they already specify how to get int here, but I'm not sure if it's here or I have to search for it. Maybe somewhere else. Let me check. I want to copy paste as much as possible because then it not only avoids errors, but it's much more easier and makes my development time a lot faster. So if I go to notes here, let's just check for get int. I believe in the notes here, they also give how to do it for Mario, how to take input, initial input. Let me check that. Yeah, something like this. So you have n, and then while n is in this case less than 1, but we can change the condition. We want to keep on reprompting the user. So let me just go ahead and copy paste that. Okay, so include CS50.h. Let me just close this. I don't know why this is spinning. Weird. Okay, and then stdio.h into main, return 0. So what we want to do is we want to first get the height, right, which is n in this case, but we want to reject inputs where n is less than 1 or n is greater than 8, right? Yeah. So we want to only take in input when n is between 1 and 8 inclusive, right? We can also write this as not n is less than n is greater than or equal to 1, n is less than or equal to 8, not of that. And this is saying that while this isn't true, keep on repeating the loop. So while this is not valid, you want to keep on reprompting the user. So after we come here, we know that n represents height and is a valid one, valid integer between 1 and 8. So let's think about the crux of the problem now. It's basically we want to display the pyramid, but how are we going to display it, right? So that's the question here. So in simple terms, what we can do is we want to display this pyramid. Let's take height of 4. It's easier to analyze, right? So let me copy paste that. So if this is the pyramid, we want to print 4 rows of the pyramid, right? So if height is 8, right, for instance, in the original diagram here, we want to print 8 rows, right? So that's a good starting point. We want to print 8, we want to print height number of rows first. So let me go ahead and do that. So for int I equals 0, I is less than n, I plus plus. Probably going to change n to height. It's easier and more cleaner to read. So let me go ahead and do that right here. Boom, boom, boom. Okay, so while I is less than height, I plus plus. Okay, so for each row we want to print that. Okay, so we want to print hashtag, right? For each row, right? So how do we print a hashtag? That's just printf, right? So that's pretty straightforward. But how many hashtags do we print out? Do we print out, I don't know, the height number of hashtags, or do we print out some like other number of hashtags? That part we need to figure out. So let's take a look at this. So we need to print out. Okay, so if the row is 1, right? So this is row number 1. So this is row number 1, and this is row number 2, right? So if this is row 1, we need to print 1 hashtag. If this is row 2, we need to print 2 hashtags, right? So we see a pattern here, right? So in other words, for every row, we need to print out row number of hashtags. So basically the current row number of hashtags. So let me go ahead and make this a little easier. So I'll just say int, try to maximize this. Int row equals 1. We could start from 0, but it makes the mathematics a little bit easier if we start from 1. So row is less than height, row plus plus. Okay, so print hashtag for each row, print row number of times. Okay, so that's pretty straightforward. You know, j is less than equal to row j plus plus. You print f a hashtag. That's it. Okay, so that part we have it down. So every row we print out row number of hashtags. Okay, and then after each row we also need to print out a new line, right? Because once it goes to the next row we want a new line there. So let me go ahead and print f new line. Okay, so just to repeat here, we have an outer loop that just prints for each row, right? Which goes through each row, and for each row, inside each row, we want to figure out how much hashtags to print, how much spaces to print. So in this case, we do this. So if you only do this, right, let's see what happens. So let me go ahead and do that. So let me go ahead and make Mario. Width, it should say height, but let me give 4. So we have something like this. Okay, this is not entirely correct, but at the same time it's sort of half right? Because for each row we print ones, we print 2 hash, we print 3 hash, we print 4 hash. So that's sort of exactly what we want here: 1 hash, 2 hash, 3 hash, 4 hash, right? But the spaces is the key here, right? So we need to add extra spaces to make it right aligned as opposed to left aligned, right? So let's go ahead and change a few things. So first of all, it should say height, not width. So let me copy paste that. Okay, so now we also want to print space to make it right aligned. Okay, so let me go ahead and do that. So for int k equals 1, k is less than, okay, so the next thing we want to do is we want to print out spaces, but need to figure out how many spaces to print. Okay, so this is the real tricky part for this problem. Okay, if we actually think about how many spaces to print, right? So let's take an example here. So for row 1, we want to print 1 hash, and then how many spaces? 3 spaces, right? Because these are invisible characters. If you represent them by dot, it'd be easier to see. 1, 2, 3, right? For row 2, we want to print out 2 hashes and then 2 spaces. These are rows, but you could put dots there. For row 3, you want to print out row 3. We want to print out 3 hashes and then 1 space, right? So how many spaces do we actually need to print? If you actually closely think and examine it, for each row we have spaces plus hashes equals total height, right? What I mean by that is for row 1, we have 3 spaces and 1 hash, 2 spaces and 2 hashes, 1 space and 3 hashes, right? So if you have, how many spaces we have to print? We have to print total height minus the hashes, right? So in this equation, total height minus hashes will give you the number of spaces for each row. So all we have to do is say from 1 to total height, which is height, minus the hashes, which is nothing but the current row number of times. We want to do this. Okay, so and then we just do print f space. We could print dots here, but I'm just going to skip this step for now. Okay, so let us go ahead and see what this prints out now. Okay, so I'm going to do make Mario 4 or 3, whatever. We don't have this quite right. I believe it's the loop condition. Let us quickly check what's happening here. So when this is true, what do we get actually? We want to print three hashes, and then let me see. Oh, this should be equal. Yeah. So the error in my program was that since we started at 1, it has to be less than or equal. Alternatively, you can also start from 0 and do less than. But any case, so this is how we want the logic to look. That should pretty much be it. So let us just compile this program. We already compiled it. Let me just check this invalid input scenario here. -1, 0, 4, 4250, 4254. Okay, so this works. So that's pretty much it. Let's go ahead and submit it also. Check CS50. Actually, let's just go ahead and submit it. And we have to wait for some time here. Okay, so while that completes, let me just go ahead and make the next create directory for the next problem. So here we're gonna make directory for Mario more. So Mario more, change directory Mario more, touch Mario.c, clear. Okay, so now we have Mario more here, Mario.c. We can copy paste whatever we have from Mario here, and then actually let's first check if we got it correct. Actually, oh, I think I cleared it. So let me go back here, open it. Okay, style is 0.84, but you know, but we got 10 on 10 for functionality, which is good. Okay, so let's move on now to Mario more. Okay, so let me copy paste all I have here to Mario more here, and we'll close the other one. Okay, so in Mario more, we want to do the same exact thing as Mario less, but the only difference there is that we want to, let me open it again, is that we also want to print, besides the right align pyramid, we also want to print out the left align pyramid, but we already know how to do that since we sort of, while we're building it up, we sort of explored that. Okay, so for each row, we, in addition to printing wherever we currently print, we also have to print 2 spaces here always, because that's for each row, right? And we also want to print out 1 hash, the same number of hashes, but there's no additional spaces after that. So 1 hash, 2 hashes, and so forth. So all the only change we need to make in a given program here is after we print this, right? We want to print 2 extra spaces, right? Which we can just write another loop if we want, or we can just do something like this. And then do that, and yeah, and then after that we print out, you know, hashes, right? So like so, and that should pretty much be it. Let's just quickly test it out. So make Mario, and then Mario, hide, say 5, yeah, boom. Okay, so let's quickly also submit this. It should be pretty straightforward. That's the only change we need to make, basically. Just to repeat again. So we already printed the left pyramid for Mario less. All we have to do additional stuff is print out 2 additional spaces and then the same number of hashes. That's pretty much it. And let's go ahead and submit this. And if you're curious, I've already, for input 2.txt, I've already put the character Y, so I don't have to type in Y because when you ask for submit, it asks for yes or no. I don't have to do submit, redo that. Okay, so now let's move on to the next problem. So let me close this. It's cache. Okay, so let's quickly take a look at that. So let me go ahead and create a folder, make directory cache, and then also while I'm at it, credit. Okay, so change directory cache. So now here what I'm going to do is I'm going to touch cache.c. Okay, so let's go to cache here. In cache, the exact objective, and I encourage you to read this, it's kind of useful context, and also watch the walkthrough video. It's really useful. The context in cache is that you want to just print out the amount of coins that are used for the given change, right? So as an example here, if it's 41 cents, you want to print out 4, which basically means you have 1 quarter, 1 dime, 1 nickel, and then 1 cent. So it's 4 coins. So we want to print out the minimum number of coins pretty much. So that's pretty much it. So let's go ahead and try to attempt cache now. Okay, so for cache, I guess I can use the same template here. Before that, let me quickly open this and see if Okay, we got 10 on 10 for the functionality. Style is questionable, but yeah, okay. Let me go here, and then for cache, copy paste this, boom, okay. So now let us try to attempt cache. So for cache, we want to first take an input in which we have to use get float, and then we have to do change ode, same exact idea. Float change equals get float, and then we pass in the change. Let's copy paste this to avoid any spelling errors. Good. Okay, we haven't changed now. It's pretty straightforward. So after this point, what we want to do is we want to convert this into integer number of cents, right? So as an example, 20 would get converted to, would safely convert to 20, the integer 20. So we can easily use division and modulus and sort of get even amounts. So let me go ahead and do that. Okay, so after this point, what we want to do is, yeah, so now we have the amount of cents, and we want to find out the total number of coins owed. So change and coins 0 printf, and you want to do some algorithm, and you want to print out the coins or the change owed, right? And then coins. Coins. Okay. So now we want to figure out how we want to code this up. So we have the cents, right, which is the denomination. So as an example, 41 would be 41 cents, etc. Right? So now what we want to do is pretty much have, yeah, what is this actually? Delete, close. Okay. So now what we want to do is pretty much we want to compute the change required, right? So let's take some examples. So if we have 41 cents, right, you want to first start off and think about how many quarters we can divide it by. So as an example, 75, right? How many quarters is that? That's 3 quarters, right? How did we get that? We just did 75 divided by 3, right? And the remaining amount, we want to keep on dividing and trying to find out how many other coins we can make using other coins, right? So as an example, 75 is 3 quarters, and we divide that, and then the remainder is 0 because there's no remaining amount, so others will be zeros, right? So the total coins in this case would be 3. Let's take the example 41, okay? So 41, we first divided by 25, right? That's just 1 quarter. We want to take the remaining amount, which is in this case a 41, 15, 16, right? So 16, we want to divide that by 10 next, and we get 1 dime, and then we take the remaining amount divided by 5, so we get 1 nickel, and we take the remaining amount and we divide it by cent, which we get 1 cent, and the remainder is 0 after this point. 0 is the remainder, right? So the idea is to start off from 25, keep dividing to extract the total number of coins. Alternatively, if you want, you can do minus, but that's just inefficient because it's doing multiple iterations of just subtracting. So as simple example, say you want to multiply something, you can just keep on adding n number of times, right? Instead of multiplying by n. So you can do that too, whatever works, however you want to think about this problem. I personally prefer to do it this way. So let's go ahead and try to do it this way, right? So what we want to do is we want to, so when do we want to stop? We want to stop when there's 0 remainder, right? So while cents is not equal to 0, right? Keep on dividing stuff. So first we want to do 25, right? So we do, let's think about this. Coin plus equals cents divided by 25. And then cents equals cents modulo 25, right? So that's exactly what we did here. So 41 we first divided by 25, right? So we get 1 quarter when we take the remainder for the next iteration and for feeding that into our 10 counts, right? We want to do 5 counts and we want to do 1 counts, right? Okay, so now we do coins, same exact idea. Now we have remainder of 16. We divide that by 10. We take coins, we take cents equals cents modulo equals 10, we take the remainder basically. And we just keep on doing that, right? So let me just copy paste here, right? It's much easier. So we change this to 5, 5, 1, and then 1. So towards the very end, we should print out the total number of change owed. So let's just run through this real quick. So let's take 41 as an example. 41 is not equal to 0. 41 is going to divide by 25. It's going to extract 1/4, right? And then 41 modulo 25 is going to take the remainder, which is 16. And 16 is going to get divided by 10. And we just do all these calculations. And we're taking the remainder as we go on. In the last iteration, we're going to do 1 divided by 1, which is 1. We add that. And then since 1 modulo 1 is 0. So we print the total number of coins after we finish the loop here. So let's quickly compile this and see if this even compiles. Okay. Okay. Double implicit. Do I have to import some library? Math, maybe? I don't know. Let me check. Include math.h. No. Okay. Oh, dollars. Okay. This should be, yeah. Okay. Let me change this to dollars. Okay. So let's just test cash, change owed. This case 0.41 maybe. I don't know. 4, is that correct? That is correct. Okay. And the get float already handles all these cases, so I believe we don't have to do anything, or I might be wrong on that one. Actually, I might be wrong on that one. Let me check. Oh yeah, so that's wrong. Okay, so we also want to add some conditions around that. So let's yeah, so let us add some conditions around that. So we want to actually validate that it's correct, and I believe it also gives hints on how to solve that. Maybe not, I don't remember. If user fails to provide on your program, you will be prompt. Okay, so in the same way as Mario, let's do that also. In Mario, we had a do while loop, right? So let's keep on doing this, something like this. So we have float dollars outside. Inside we have dollars equals this. And then while dollars is not, okay, let's do this. Well, dollars is less than 0 or negative or what? Negative. I think so. I think maybe that's pretty much it. I might be wrong. We can come back to it. Let's check. Make cash. Okay, sorry. -4. -0.41. Okay, what about foo? Okay. So I think this works. And then 0.41. Okay, so now let's try to check with CS50. Okay, so this passes these tests. Let me go ahead and try to submit this also. Oops. Okay. So hope that makes sense so far. All we do is just divide it by max amount, and we just keep on taking the remainder as we go along. So this is how I personally have done it, but there are multiple approaches. Some people might subtract, some people might multiply, etc. So that's pretty much it. Okay. Okay, so let's check this also. So while we're on it, let's move on to the next problem. Next problem is credit, I believe. So let me just open credit. Okay, while this is going on, let me just do it. Okay, so credit. So credit is also kind of tricky. Okay, so let us open credit now. Okay, 11 out of 11. Style questionable. Okay, that's fine. I'll take that any day. Okay. Okay, so now let's focus on credit. Okay, so credit is pretty much the idea in credit is that you're given a credit card number, and I encourage you to read through all this, and also watch the walkthrough as usual. Actually, the walkthrough is probably the most important video, even if you don't read this, because it's very useful. Sometimes it's even more useful than the actual prompt itself. So in the credit, the idea is you're given a credit card number, and you just want to figure out if it's a valid credit card number, and what credit card it actually is, like what type it is, whether it's Visa, whether it's MasterCard, or American Express. And they give some conditions for this, and you have to use this sort of checksum algorithm called Loon's algorithm. I don't know how to pronounce it, but that's the idea of it, at least. So as an example, I mean, you could read through this, but the idea is that you have to go through every alternate digit starting from last, and you have to multiply by 2, and then you have to reduce that and add that to every other digit's sum. And if the last number in that is 0, then it's legit 1. Okay, so yeah, let's sort of go through this. There's multiple approaches for this problem also. I did not use arrays in this problem. I just used longs. The reason being that arrays is taught in week 2, so I only wanted to use the knowledge that we learned until week 1. So that's my primary objective, but I have seen some people use arrays, which is totally possible, and you can definitely do it using that. Okay, so now so now let's go ahead and get started. So what we want to do here is we want to first take in the number, right, as a long, right, and we want to keep doing that until it's a valid get long will reject hyphens. Okay, yeah, so we want to do it until it's a valid long, right? So let's do that as a first step. If you were to do it as an array or string, then you have to do a lot more validations, which would be kind of annoying. Okay, so let's go ahead and copy the same thing from Mario. Copying it from your previous programs is much easier. The reason being that you're not going to make as much as errors while copying, and then the same template can be reused across different things, right? So let me go ahead and do float credit. It's representing the credit card. Actually, sorry, long, and get long. And then all you're going to do is pass along the credit number. So number this. Okay, so credit is, let's check. So looks like the condition in our case should be, it should just take in a valid credit, and if it's a valid credit, it should okay. Yeah, let me think about what the condition should be here. Give me a second. Okay, yeah, I need to think about the condition, but currently I put credit is not equal to 0. So what we can do is inside here, we want to validate the credit card. So validate the credit card as long as, you know, the credit is not equal to 0. Then run the Lund's algorithm for valid credit card detection, and we'll reduce the credit to 0. In a sense that we're going to run the Lund's algorithms and divide by modulo 10, divide by 10, and eventually reduce the credit to 0. And then we capture that total sum in some variable. Capture total sum in some variable, right? So as an example here, let me show what I mean. So if this is a number that's inputted, this is not equal to 0, so I'll reduce it to 0. Meanwhile, I'll run this algorithm, and when I break out of the loop, it should be the value in the total sum should be 20. So let's do that real quick. So so let me go ahead, and so after this, let me introduce another variable called total sum equals 0. Maybe it should be like this. I don't know the conventions here, but yeah. So what we're going to do is oh, by the way, I'm going to write everything inside main. That's not recommended. It's typically recommended to create your own functions, etc. But just for the sake of argument, I'm just going to do it here. Okay. So if total sum mod 10 is equal to 0, then it might be a valid card, right? Else it's not valid. Okay, so what will happen here is, as an example, say we run through this Lund's algorithm and we see that the total sum is 20. So 20 mod 10 is equal to 0, so it might be valid, right? We want to check also other constraints, right? So it might be valid or might not be valid. And then else we want to check for else it's invalid pretty much, because the credit card number itself, the checksum, doesn't check out, so it's not a valid credit card. So let us go ahead inside here and do the Lund's algorithm. So let's think about how we're going to do this, right? There's multiple approaches to solving this problem, but I think the easiest way for me, the way I approach this problem, is I extract the last digit and keep moduloing by 10 and dividing by 10 every time. So let me walk through how that looks like, right? So say you're giving, and this is related to parity, or mostly the parity of the indices, right? So you're given the number 1, 2, 3, 4. Think about how you would find the sum of, say, 1 plus 3, or you want to find sum of 2 plus 4, right? In other words, you want to find the sum of odd indices and you want to find the sum of even indices, right? How would you do that, right? So if you can solve this problem, then you can solve the checksum problem, because you want to pretty much find every alternate position starting from the last, and you want to sum it up. So how you would solve this particular problem is, say you want to find sum 1 and 3, right? You first take 1, 2, 3, 4 modulo by 10, and you get 4, right? And you also want to maintain a position called index, the current index, right? It's going to become 0 starting from the last, right? So now position is 0, which means it's a even index, right? In the next iteration, you want to divide by 10, so the number will be 1, 2, 3 mod 10, and you get 3, the next digit. But in this case, position will be 1, which is odd, right? And then you divide by 10, so in the next iteration it will be 2, so position will be 2, and this is even parity because its position is 2, and so on. So you keep reducing this down eventually to 1 divided by 10, which is 1, position equals 3, which is odd. So this is every other digit, right? And then you divide it by again, so it reduces down to 0. So this is how you can execute the Lund's algorithm using another variable called position, and the position is going to get incremented on every divide by 10, so that you can just read the position value, and you can just take the parity of it and decide whether if it's an odd index, then you're looking at every other digit, and if it's an even index, you're looking at every digit starting from last, right? It might sound a little confusing, but if you just write this down on a piece of paper and sort of execute it yourself, you're going to see what I mean, right? So let's do that here. So while credit, we want to reduce it. Okay, let me leave the comments down. While credit is not equal to 0, we want to keep on executing this algorithm in which we want to increment position, right? So let me introduce another variable here, position. So int position. Okay, so if position mod 2 is equal to 0, then we're looking at, if it's odd, then we're looking at every other digit, right? Starting from last. If it's even, then we're looking at every digit starting from last, meaning 4, 2, etc., right? So let's do that here. So, and then we want to capture the total sum somehow, right? So, okay, let's go through this algorithm here. So what we do is we take every other digit multiplied by 2, right? So let's do that right here. So we want to do credit mod 10 will give you the last digit, credit equals credit divided by 10 will give you the other digits. So what we want to do here is want to do total sum plus equals 2 times credit mod 10. And then similarly, if you're here, we want to do total sum plus equals credit mod 10. Okay. So if we do this right now, so what we do is we take every other digit. So when it comes to say this iteration, it would be just before 00, this entire number here, this entire long, right? And position will be equal to position. Okay, let's run through this real quick. So position will be 0 initially, which means it's a even digit. So it's a very starting digit. So you just take mod 10, right? So it'll just add 4 in the first iteration, right? On the next iteration, you increment position. So position will be 1. So now 1 is an odd index, right? So that's why he goes here and does 2 times 1, right? So in this case, 2 times 1 is 1. So, and then in the next iteration, position is going to get incremented, and you're going to do the same exact calculation, right? So, and then the important thing here is it's going to reduce down because you divide by 10 every time, okay? So that's the first step here. So this is fine, but it gets a little tricky here because when you multiply it by 2, you can end up with 2-digit numbers here. So as an example, 6 times 2 here is 12. But we don't want 12. We actually want to reduce this down further into 1 plus 2. So we want to take the sum of 1 plus 2 here. So let's go ahead and do that here. So once we do it, so let's do int temp equals 2 times credit mod 10. If temp is greater than temp is greater than 9, right, meaning it's a 2-digit number, what do we want to do? We want to do total sum plus equals temp mod 10 plus temp divided by 10 plus temp mod 10. This might sound a little confusing, but it actually is. What I'm doing here is if it's, say it's 12, I want to do 2 plus 1, right? So how do we get 2? We just mod it by 10. How do we get 1? We divide 12 by 10, which is 1, and then we do temp mod. Actually, might be easier to write it as here as like this. Actually, sorry, my bad. Let me do it. Let me think if there's an easy way to write this. Temp mod 10 is 2. So in this case, 12 divided by 10 is 1 plus 2. Yeah, so if it's something like 19, it will be 1 plus 9. So how do we get 9? We mod by 10, right? And then to get 1, we took 19 divided by 10, right? So it should be like so. I believe that's correct. Let me check that though. So outside here, let me print total sum equals, this is a checksum, and then let me print out the total sum. Okay, so let's just quickly run through this because I don't know if it will work. Let's quickly try it. Yeah, let's try it. It's kind of interesting to see what would happen. So let's first make it. Okay. Print f expected while. Okay. Oh, sorry. Yes, this should be outside here. Okay. Okay. So credit was the number. This was the number, or let me just copy from here. Same thing. 32. Okay, so that's clearly wrong. Let's see what we did wrong here. Oh, else total sum plus equals temp. Okay, so that's one problem. Okay. Let me copy it again, paste it, 20. Okay, so what we did here, just to reiterate, is that we want to capture every other digit, right? So temp mod 10 will give me the last digit, and then temp divided by 10 will give me, so say it's something like 19, right? We want to do or 12 as the example. We want to do 1 plus 2, which means we want to take the modulo 10 and we want to divide it by 10 also. So 1 plus 2 is, in that case, will be equal to when you do 12 divided by 10, you're going to get the digit 1. Okay, so that's what we want to do. Okay, so that's pretty much what we did here. So yeah, so after this, if total sum mod 10, it might be valid, else it's not valid, right? So we want to fill in this gaps. So yeah, so let's go ahead and try to validate here. So now validation is a little bit tricky because you want to compare the length of the credit card as well as the what's it called, the starting of the credit card, right? So in order to do that, anyway, we divide and reduce it down here. So we might as well keep a track of the total count. Total length equals 0, and we increment it here on every iteration. Okay, so that's good to go. So let's go ahead and delete this piece right here. Okay, so we did that. So now we have access here. So it might be valid, but we want to check, right? So how do we check this? So if there's additional constraints on this problem as well. So it has to start with some numbers like 34, 37. Let's take the largest digit number. So in this case, this credit card will be MasterCard, which has 16 digit numbers, right? So let's try to think about how we can do that. So let's take a MasterCard example here. Let's go here. PayPal. Yep. So if you take a MasterCard example here, what we want to do is this. We want to compute its length, right? We already have its length. We want to check the initial few characters and see if it's a MasterCard or not. So let's go ahead and do some validation. So 16-digit numbers, and MasterCard starts with what? All American numbers start with this. Okay, let me just copy paste this. Okay. And MasterCard start with this. Visa numbers start with this. MasterCard uses 16-digit numbers. Uses 15-digit numbers. And Visa uses 13 to 16-digit numbers. So using this information, what we can do is we can first check the 16-digit case, right? So if so we want to also check the sort of starting digits. How might we do that? We just divide it, right? So as an example, right? If let's check American Express since it's 15-digit only, right? So we might say something like if actually let's capture the starting parts initially, right? So part 1 equals this divided by 1 followed by it should be credit, followed by 15-digit numbers. So we want to say 3 or 4, right? So what we actually want to do, and there's one other problem here, right? So the credit number is actually lost here. It's equal to 0 because we divide it in every iteration of the loop. So let's go ahead and make a copy of it before we actually use it, right? So let's say long credit copy, okay? And then credit copy equals credit, okay? Let's make a copy of that. Okay, so now we actually want to use the credit copy here, and we want to just do this. So let me open Python real quick. The reason why I want to do that is it has a nice interpreter, so I can just well, actually I don't need to, maybe I don't need to do that. I can just have a new terminal here. Okay, so let me just do this. Divided by 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, no, 14. So that'll give me 51, right? So 51 is a valid MasterCard. So let me go ahead and do that. I want to extract all these individual starting parts, so I just keep on dividing by some crazy large number, like 1 followed by how many amount of zeros to extract those individual digits. That's exactly what I'm planning to do. So let me go ahead and do that. So part 1 equals this, 1 followed by that. Part 2 equals, and I'm going to map these parts to these things individually. So the 5100 was again a MasterCard, so it's 16 digit, right? So in order to get this, I did that, right? So this is this corresponds to MasterCard start, okay? Similarly, I want American Express start. Okay, so American Express start, it's also 15 digits, so I just take that and 15 digits, so boom, okay? Similarly, actually, let me make it long. Actually, I don't need to because numbers will be 52 or something, which will easily fit inside integer. So I realize I don't have to do that, but let me do that in any case. Actually, I don't need to do it, but you know, whatever. Okay, so Visa numbers, Visa start equals credit copy. So Visa is a little tricky because it can be 13 digit or 16 digit. So we already take care of 16 digit case here. So let's also do this 13 here. So 1, 2, 3, I believe, right? We'll come back to it. We can add some validations here. So let's do MasterCard. Sorry, American Express first. Okay, let's do American Express first. Okay, if Amex start is equal to 34, or Amex start is equal to 37, then that's a starting of the credit card. We also need to determine if the count, right, and the count, right? So that's another condition here, and the total count is what we total length is equal to 15 digits. Then what we want to do is we want to print F American Express, right? Amex. Oops. Okay, so that part is done, taken care of, right? Else if okay, so after that we want to also we want to return after this, right? Because we printed a valid credit card. After that, the next step, what we can do perhaps is this. So we took care of American Express. Actually, we can test it out as we go along. That'd be easier to see, probably. Make credit, okay. Return 0. So this was American Express. Oh, sorry, that was MasterCard. Yeah, that was MasterCard, sorry, yes. American Express is this, okay. So let's quickly test that. Okay, great, that works. What about this one? Okay, that works. Okay, so that part we have it down. the next part is a little tricky because it needs to be 16-digit integers, right? So else if total length is equal to 16 digits, then we know it has to be a Visa or it has to be a MasterCard, or total, actually, yeah, or the total length is equal to 13, then it has to be a possibility of Visa card. Else we know it's invalid already, right? Printf invalid and return. Actually, we don't need to put return, but right. Does that make sense so far? So what we're saying now is basically, if total length is equal to 16 or 13, these are the Visa or the MasterCard scenarios, right? So let's compute this. So the way we know it now, is that if it's a 16-digit thing, right? If MasterCard start is greater than or equal to 51 and MasterCard start is less than or equal to 55 within those inclusive numbers, right? We already validated the 16-digit stuff, so then we know it's a MasterCard, right? So let me go ahead and do that. Yeah, so in this case, printf MasterCard, then return 0. Okay. You know what? Actually, to be more precise, it would probably be better if I move this here, and also do something like this. Okay, so because we strictly know now this is MasterCard. Okay. Let's move this here. Okay, so MasterCards. Okay. Last is Visa, right? Yeah, so for Visa, what we do is we do the same exact thing, but if the total length is equal to 16, right? It could be 16 or 13, right? So let me check this out. All I need to do here is do something like this: 16 or total length equal to 13. Then I need to see if it starts with 4, right? So in order to figure out if it starts with 4, what we can do is Visa start equals 4, right? Or if it's a 16-digit number, right? Then we also need to we already computed this MasterCard's 51, right? So it already extracts the first 2 digits for MasterCard. So all I need to do is verify if it starts with 4. So what I can do is say something along the lines of MasterCard start mod 10 is equal to 4, right? Because all Visa cards start with 4. And hopefully that should take care of the scenarios. And it returns 0 early on. So if it doesn't return 0, then it's invalid. So let's quickly check. Okay, so clear, oh, sorry. I didn't make it. Make credit. Okay, tons of errors. MasterCard undeclared. Oh, I see. So the parentheses were messed up. That was causing the problems. Okay, now it's fine. Okay, add extra set of parentheses there. Okay, so now let's recompile this. Okay, so that's fine. Let's test it out, actually, interestingly. So number, let's feed in. We already tested American Express MasterCard. Okay, saying invalid, which is wrong. Let's quickly test why that's the scenario. MasterCard start equals MasterCard start. Yep. $22. Why is it 22? MasterCard start with. Oh, I was taking the wrong example. Sorry. This example here. So even though these are valid, the prompt specifies that, you know, you can ignore those. I was taking the wrong example here. MasterCard. Okay, that's fine. That's exactly what we want. What about the Visa? Let's test both this Visa. MasterCard start equals 0. Okay. That's fine. Let's print F Visa. Visa start. Let's make it. And then copy paste, blah blah blah. 42. Oh, okay. So we want to include one other 0 here, and that should probably solve it. I think we were just dividing it by 1 0 2 less. Visa. Okay, Visa. Okay. Okay, let me just remove this annoying print statements. Okay, so let me try to do this. Oof. Okay, that's invalid. Let's quickly check why that could be the case. Visa start. Oh yeah, right. Because if it's 16 digit in length, yes. Okay, I see now. Okay, but let me quickly check something else. MasterCard start. Yeah, sorry, this should be divide. Yeah. If you divide by 10, then for the MasterCard, since it's also 16 digit, we don't want 2 digits, we want 1 digit. So divide by 10, we should get 4. Right. Yeah, I think so. I think that should do it. Let's quickly check. Oops. Nope. Credit. Okay, Visa. Okay, so yeah, kind of confusing, I know, but this is how I, at least, my thought process is. Let us go ahead and sort of run it against the checker here. Okay, so this all validates, this passes. Let me go ahead and submit it. Again, this can be confusing. So to reiterate what I've done is I first run the Lund's algorithm here and make sure I reduce the credit card number to 0 while it's a valid long, right? After I do this, then I have the total sum captured here. So I know that if the total sum last digit is not equal to 0, then it's not a valid credit card number, and it goes here and prints invalid. If it is a valid credit card, then I have to validate all these conditions here, which is MasterCard, Visa, credit card. And I can do that because I know the total length that I've captured while I was dividing here, as well as the starting 2 digits or starting 1 digit, depending on how much ever you divide by, right? That's exactly what these are doing here. So yeah, that's pretty much it. Let us go ahead and try to open here. Okay, 15 out of 15. Okay, that's perfect actually. 15 out of 15, but 13 out of 13 18 days ago. Okay, strange. Maybe they added two additional cases, maybe. I'm not really sure, but anyways, this passes. Sorry if this was really confusing and took some time, but hopefully it helped. This is sort of live coding, so obviously I make some mistakes as I go along. So please apologies regarding that. But hopefully this makes sense, and yeah, that's pretty much it. If this video was helpful to you, please let me know. So that's pretty much it. See you guys in the next video where we go ahead and do problem set 2 for the CS50 course. So stay tuned, enjoy, and stay safe.